fourth unit, it is regarding of the successive and partial differentiation. Okay, so I have told the representation of the orders also. That is how you'll write the first order, second order, third order, so on up to nth order. So the representation also given, and even see the standard functions, nth derivative of some standard functions. Okay, so those just I am telling the that is ax plus b to the power of m, or log ax plus b, a to the power of mx, e to the power of mx, sin ax plus b, or cos ax plus b. So these are the important standard functions. Okay, these functions nth orders they will ask in the objective type of question as a formulas that you may get in the multiple choice, or it's the fill in the blanks also they will give. Okay, so if you know these all standard function formulas, these whatever the fourth unit is there, in that you can solve the problems. Okay, so these standard function formulas of nth order are given in the textbook. In one page you write all the formulas and try to remember them. Okay, so in this unit we have seen already, last week I have told one problem for finding the fourth order of the given function. How to find the fourth order means whatever the given function y equals to f of x is there, for that function you go on doing the problem. I observe the formula was problem y equals to a cos mx plus b sin mx. Okay, that one we have done. So on that you can see the example of one more problem, same one you will have. So if y equals to e to the power of, so like this, if y equals to e to the power of minus x cos x, then show that d to the power of 4y by dx to the power of 4 plus 4y equals to 0. Okay, this is the 5 marks problem you will get. So here last week whatever see in the problem, in that only one function was given, in between plus sign was there. So whenever it is a plus sign is there means directly we can do going on doing the differentiation. Here two functions are there, one is e to the power of minus x, one function, another one is the cos x. Okay, two function means we have to follow the UV rule. Okay, so you have to keep any one as a constant, and the second term you have to do the differentiation. So you can take in the solution, that is let y equals to e power minus x cos x, and you put it as equation 1, and you write it as you differentiate 1 with respect to x on both sides. Okay, or else you can write on differentiating 1 with respect to on both sides we get. So what you'll get, y means it is dy by dx. It is equals to, this is u and this is v. So uv formula is you have to keep any one term as a constant, and second one you have to do the differentiation. So e to the power of minus x, if you take it as a constant, and cos x differentiation is sin x, that is minus sin x. Okay, next e to the power of minus x. So if you remember the differentiation formulas, e to the power of x formula is always, if you do the n almost any terms means any number of times, you will get the same one. E power minus x means minus e to the power of minus x only. Okay, so here minus x is there, so you'll get is the quotient minus x cos x, you write like that only. From these two you take minus e to the power of minus x as a common, so sin x plus cos x, and you take this as equation 2. Okay, now differentiate 2 with respect to x on both sides. You can write here again differentiating. Okay, so second order means you will get d square y by dx square is equals to, again this is in the form of uv. Okay, so minus e to the power of ex is there, and sin x plus cos x. So this you keep as constant, that is minus e to the power of minus x, and when you do the differentiation of this one, cos x minus sin x. Okay, this is u is the constant, and we have done the differentiation. So next one, if you will take again e to the power of minus x, differentiation is minus e to the power of minus x. So minus of minus, it will become plus. So plus e to the power of minus x, and v you keep like that only. So sin x plus cos x. Okay, now you can multiply this with e to the power of minus x. So e to the power of minus x cos x. Here minus into minus is plus, e to the power of minus x sin x. and here e to the power of minus x sin x plus e to the power of minus x cos x, and see whether any terms are getting cancelled or not. E to the power of minus x cos x minus is there, plus is there, so both will get cancelled. So you will have e to the power of minus x sin x. Okay, so now this is the, you can take it as the third equation. Now you write again differentiating 3 with respect to x on both sides. Okay, so what you'll get, third order. So in the given question, what it is given, he is giving the, to find the fourth order. So 4 times you have to do the differentiation. Okay, next third time means d square y by dx cube, sorry, d cube y by dx cube, it is equals to, again this is uv. Okay, so 2 you take as a constant and e to the power of minus x. So 2 you are taking common because it is a multiplication of both the terms. So 2 keep outside, and e to the power of minus x is the constant one. Sin x term is cos x, and again e to the power of minus x differentiation is e to the power of minus x sin x. Okay, so 2 you keep like this only, or else you can from these 2 terms you take e to e power minus x outside. So e to the power of minus x, if you will take outside, it is cos x minus sin x. So it is 2 e to the power of minus x cos x minus sin x. So it is the fourth one. So we need a d to the power of 4 by this, no? So now again this is in the form of uv only. So whenever you do the differentiation of 2 terms, then you'll get all the uv terms only. So now you write differentiate 4 with respect to differentiate 4 with respect to x on both sides. Okay, 2 is the common for these 2, no? So take so what you'll get here, d to the power of 4y dx to the power of 4. 2 you take as the common for both the terms, and here e to the power of minus x is the constant one. Now differentiate of this one. So it is cos x differentiation is minus sin x. Sin x differentiation is cos x. Okay, now again differentiation of e to the power of minus x is minus e to the power of minus x, and this you keep as constant. So cos x minus sin x. Okay, now you multiply these terms with 2, or else you can keep like this only, you multiply this one inside one. So it is minus e to the power of minus x sin x minus x cos x minus e to the power of x cos x minus into minus plus e to the power of minus x sin x. Okay, so which terms will get cancelled? These 2, e to the power of minus x and e to the power of minus x sin x. So when these 2 will get cancelled, the remaining is this one. So if you add those 2 terms, you will get it as, so yeah, it is the power of 4, it is the power of 4. It is 2 into, this is minus, minus means minus 2 e to the power of minus x cos x. When you multiply this, minus 4 e to the power of minus x cos x. Okay, so what is this? Minus 4 into e to the power of minus x cos x. Minus 4 you take out. So what is that? E to the power of minus x cos x is y. So it is equals to minus 4y. Here you can write from 1. You can see from equation 1, this value is y. So minus 4y. So what is given? That is d power 4 y dx to the power of 4 plus 4y equals to 0 we have to show. Therefore, d to the power of 4y by dx to the power of 4 plus 4y equals to 0. Okay, whatever given in the question, we have got the answer. So like this, if it is given 4th order, 3rd order, 2nd order, or any order, the procedure is the same one. Okay, like this you have to follow and you have to solve the problem. So such type of problems you will get for the 5 marks question in the section A. So next, if you'll go to the nth order derivatives of the problems, if only one function is given in the question, okay, we can use with the help of the successive differentiation. That is only one Function is given, single function is given. You can use the successive in the sense same one, finding first order, second order, third order up to nth order. That is called as a successive differentiation. Okay. Whenever two functions are given in the question, we'll use with the help of the Leibniz theorem. Okay. Leibniz theorem is useful to find the nth derivative of the functions, two functions when they are given in the problem. Okay. That is the difference between the two. So these, whatever the nth orders are there, these two problems, any one nth order one, you will get as a 10A question. That is a 10 marks question, 10A. In section B, you will have no. So 9A and 9B will be from the block 1, and 10A, 10B will be from the block 2. Okay. So next we'll see one 10 marks question, that is the find the nth derivative of sine cube x. Okay. Nth derivative of sine cube x means here, if you see, so you can write here, let y equals to sine cube x. Okay, sine cube x, directly we are not having any formulas on the sine cube x. If you'll see the sine 3 theta also, you have the formula, no? So from that sine 3 theta also, if you'll take out, it will be just one complicated one. Okay, so the sine 3 theta, we have the formula 3 sine theta minus 4 sine cube theta. Here it is the sine cube theta. So sine cube theta means if you'll take this, you will get sine 3 theta minus 3 sine theta by whole 4 you will get. Okay. So what is sine 3 theta we have? Sine 3 theta equals to 3 sine theta minus 4 sine cube theta. So we need sine cube theta now. So minus, if it will come this side, sine cube theta equals to sine 3 theta minus 3 sine theta. That is sine cube theta equals to sine 3 theta minus 3 sine theta by 4 you get. Okay. So this you can write it as 1 by 4 sine 3 theta minus 3 by 4 sine theta. Okay, this is also one method. So y equals to sine cube theta. So sine cube, from the formula also, actually to solve such this problem, you can do any two methods here. So one method is that see, from this we got same, no? This side minus. Okay, here you will get minus sign, no?
Where minus is changed.
Minus sine 3 theta, and this is plus you will get. So that is minus here, here plus. So what you will get here? Like this you will get. 3 by 4, just convert this one. It is equals to 3 by 4 sine theta minus 1 by 4. Okay, correct, no?
Yes, ma'am, now it's okay.
4 sine cube theta, here minus sign, no? So here it is positive. So this if you get here minus sine theta. Yes, don't disturb the class. So when you take out this, so you can you can solve this problem in two methods. That is when you can take theta formula. Yes, please mute your cell phones. Okay, so y equals to sine cube x is there. So by using this formula also you can take, if this one problem you have in your textbook, it is there, that is in the check your progress, it is there, or else you can convert this as sine x into x like this also. That is sine x into sine square x. So in that you need to find many formulas are there. That is sine cube x means sine x into sine square x. Again sine square x, you can write it as the cos 2 theta formula is there, no? Cos 2 theta formula means 1 minus 2 sine square theta. That formula also you can apply and then you can do. Okay. So either this one or that one. So this solution you have in your textbook. When you convert it into sine x and sine square x, same procedure you can use that one. or else this one. Okay. So when you take the sine cube x, as at the side you write whatever the formulas we have written, how you have converted this one. Okay. So directly don't write. So from this, what we got here, y equals to y equals to 3/4 sin x minus 1/4 sin. Okay.
Who is this Yashwata? Please mute your phone.
Okay. So now we got at the side you write this one. Okay. So y equals to 3/4. Please mute yourself. Ashweta.
Ma'am, host can mute everyone.
Okay. So we got y equals to sine cube x. From that we have converted it as y equals to 3/4 sin x minus 1/4 sin 3x. So how we got this one? From this formula we got. Please don't disturb the class. You will lose the time ever. Okay, only today and tomorrow we have the classes. At least today if we'll complete the 4th and 5th unit, tomorrow we can see the 6th unit. So tomorrow is the last class for you. So y equals to 3/4 sin x minus 1/4 sin 3x we got. So compulsory mention this one at the side. Okay, this part at the side you write. So from this we need to find the nth order. In the question what is asking, find the nth order of the derivative sine cube of x. Okay. Now you write here yn equals to, that is d by dx to the power of n. Here what is our y? That is the sine cube of x. Okay. It is equals to 3/4. Here for this sin x and for sin 3x, we have to write the n. We have to write the nth order. So nth order of this one is 3/4. 3/4 sin x minus 1/4 sin 3x. Okay. So from the standard formulas, whatever we have, from that we have d to the power of n by dx to the power of n sine of ax plus b formula we have. This is a to the power of n sine ax plus b plus n pi by 2. Okay, this is the formula for nth order of sine ax plus b. So here we have only ax is there, but b value is not there. Whenever it is not there, we can consider the b value as 0. Here we have a value as 3. Here we have a value as 1. So for this one, the formula is, that is d to the power of n by dx to the power of n of this one is 3/4. Here a value is 1, no? That is the quotient we have 1. So 1 to the power of n sine x plus b is not there. So b value is 0, n pi by 2. Okay. This is for this part. And this part is minus 1/4 sine, minus 1/4. Here what is the a value? A value is 3. So 3 to the power of n sine 3x plus n pi by 2. Okay. So this is the simple one. By using the formulas, we can write like this, finding the nth derivative if only one function is given with the help of the standard formulas. Here sine is there, so we are using the sine formula. So whenever cos is there, cos also same will be there. Instead of sine, you will have the cos. For log, you will have different. E to the power of x, you will have different. Okay. So this is one problem. This, whatever the standard units are there, you see those. Page number I will tell you. See 76 page number 4.2.2 example. Next, page number 77 4.2.4. Again I will not repeat the questions in whatever we have completed the units. Okay. 4.25 and 4 example, that is ax square plus 2hxy plus by square equals to 1. Then show that this one. Okay. These two are the 5 marks questions you have. Next 78 page number, third and fourth. Third one last week I have told, and fourth one today I have told the problem. These two are the 5 marks one. Okay. Please mute yourself, those who are disturbing the class. So next we have the nth derivative of some standard functions. So these are the objective type questions. That is the 78 page number 4.3.1, 4.3.2, 3, 4. And next we have 5, 6. And also 6th only, cos also is there. See in the down, note is given, no? So up to this 4.1 to 4.6, whatever are there, they are useful for solving the problems and also objective type. Okay. After that, we'll see one problem with the help of the Leibniz rule. So that is a Leibniz theorem. What it is there means, whenever we'll find the two functions are given in the question, if he is asking to find the nth order of that one, we'll use the Leibniz theorem. So what is the first Leibniz? Even the Leibniz theorem also, whatever the definition is there, that also you may get for the objective type of question. How you will represent the Leibniz theorem? So it is Leibniz theorem is that is dn to the power of y by dx to the power of n. This you can write like this. Instead of y, here we have two functions. Like this, it will be represented r else uv of n. Okay, like this also. It is nc0 unv plus nc1 un minus 1 v1 nc2 un minus 2 v2 plus so on up to ncr you will have in the middle term. Next ncn. So this formula is an important one. uv of n, u is one function, v is another function. This is with the help of the binomial theorem. If we have no binomial expansion, nc0 unv nc1 un minus 1 v1 plus this one. And here you one more formula you remember, ncr is equals to n factorial by n minus r factorial into r factorial. So with the help of these formulas, you have to find these values. Okay. So those values you have to substitute in the problem. So if we'll see one example, find the nth derivative of e power x log x. So e power x log x means in that okay, find the nth derivative of e power x log x. So here you take what is u and what is v. Formula is what? uv of n equals to this one. So you take let y equals to e power x log x. So from this, u value is e to the power of x, v value is log x. So now using the Leibniz theorem, okay, using the Leibniz theorem, we get, if we'll write this is e power x log x of n is equals to, or you can write anyway. Here we have no formula like that or like this anything. uv of n is equals to nc0 u to the power of n. So what is our u here? E power x of n into what is v? V is log x. expand with the help of the Leibniz theorem. Okay, next NC1 e power x n minus 1, okay, into log x of 1. If you write here 1, it represents the first order. Okay, next NC2 e power x n minus 2 log x of 2 plus NC3 e to the power of x n minus 3 log x of 3. So up to nth order we are writing, that is NCN e power x into log x of n. Okay. So now by expanding these with the help of this factorial, you write these all values, this one and this one, this one, this one, and NC1. If you remember the n factorial, that is with the help of the binomial theorem, we have that first term and last term you will get 1, 1. That is NC0 value is 1, NCN value is 1. After that you will change, you will get here second one, n you will get, this you will get n into n minus 1 by 2 factorial. This is n into n minus 1, n minus 2 by 3 factorial. So go on, the expansion of that one will be going on extending. Okay. So after applying those all formulas in this and you finding the values, so now you write it as NC0 value is 1. So it is e power x. E power x of n means whatever the nth term is there. So one thing you mentioned here before writing this, what is the nth order of e to the power of mx? That formula also you mentioned here. Then easily you can understand what is the formulas to write here. So e to the power of mx is d to the power of n by dx to the power of n e to the power of mx. So this formula is m to the power of n e to the power of mx. Okay. Next to d to the power of n by dx to the power of n of log ax plus b. Okay. So here we have log, here we have e power x. So this nth derivative and this nth derivative we need. So this is equals to, so what is the log? Log is minus 1 to the power of n minus 1 n minus 1 factorial a to the power of n by ax plus b to the power of n. Okay, these two formulas are important. So this is the nth derivative of e power mx and this is the nth derivative of this one. Okay. So here m to the power of n, what is our m here? 1 is there. So 1 to the power of n means it will be 1 only. And e to the power of mx means e to the power of mx. So here NC0 value is 1. E power x nth derivative is e power x only. So this you will get it as, okay, these you write in the brackets. After that, for this one, this is equals to NC0 value is 1. So e power x nth derivative is e power x only into log x plus NC1 means you will get n into e to the power of x n minus 1. Okay. So any times if you do the differentiation of e power x, you will get e power x only. So e power x into log x. Log x differentiation is 1 by x. Okay. Next you will get the third term as NC2 means you will get n into n minus 1 by 2 factorial. Okay, this one NC2. E power x only. And 1 by x differentiation. 2 times. 2 in the sense second order. So second order means this is e power x. For this only you are able to see. So okay, this is minus 1 by x square. Okay, this one e power x into 1 by x. We got here 1 by x. No, 1 by x differentiation is minus 1 by x square. Okay, last one minus 1 by x square. Next, if we'll do third NC3. NC3 is n into n minus 1, n minus 2 by 3 factorial, e power x same. Next, you will get this as 2 by x cube. Okay, this for minus 1 by x square, you are doing one more time differentiation. Okay, so how you will do that one? That is minus x to the power of minus 2. This one if you'll write minus x to the power of minus 2. So x to the power of n differentiation is n into x to the power of n minus 1. If you do that minus into minus, it will be plus x to the power of minus 3. That is 2 by x cube. So we got here 2 by x cube. So this is NC3 difference expansion. So if you'll go on do like that only, the nth order will be like this. So plus, so NCN value is 1, e power x like that only, and log x nth order. Log x nth order is, what is the formula? Minus 1 to the power of n minus 1, n minus 1 factorial. Here log x, the quotient is 1. That means a value is 1. So 1 to the power of n. So 1 to the power of n means 1 only. In the denominator also ax plus b. So ax plus b is, a value is 1, b value is 0. So in the denominator also 1 to the power of n. So it's enough of up to here if you'll write. Okay. So like this we have to expand and we have to find the differentiation of this one. And here you see, here we got x log x. After that 1 by x minus 1 by x, 2 by x cube. Next if you'll do one more means you will get x to the power of 4 you will get. So it will be going on decreasing. That is in the denominator you will get the values. Okay. So first x square, x cube, x to the power of 4, x to the power of 5, like that it will be going on. And these are in the form of 1 by x to the power of n. Okay. So when you just simplify and write, if you'll take e power x outside, that is common. If you'll take log x plus n into 1 by x, you can write x to the power of minus 1, no? Okay, it is minus 1 plus n into n minus 1 by 2 factorial. E power x we have taken outside and this is minus, no? So you can take here minus and x to the power of minus 2 plus third term. Third term is n into n minus 1, n minus 2 by 3 factorial. So I'll write down that one. So plus n into n minus 1, n minus 2 by 3 factorial. So e power we have taken outside. This is that is 2 into x to the power of minus 3. Okay. So on like this. Last what we'll get, minus 1 to the power of n minus 1, n minus 1 factorial, and this is x to the power of minus 3. So this is the expansion of e to the power of x log x with the help of the Leibniz theorem. So whatever formulas you are using in the problem, you write those formulas compulsory. Then only it is understood that the problem is done by yourself. If not, you will see the same one procedure in your textbook. Directly they will write the solution. Within the 2 or 3 steps, you will get the answer this one. So this is actually 10 marks question. So 10 marks question means if you should elaborate that problem. If you will follow the textbook procedure, what will happen? They will not mention the formulas in between. So compulsory mention whatever the formulas you are using in solving the problem. So then only you will get the full marks. That is 10 out of 10 marks you will get whenever you apply whatever the formulas you are doing and whatever the any theorems you are using or not. So if you mention then it will be apt for getting the 10 marks. Okay. So this is the 10 marks question. So 2 10 marks problems we have seen. After that, 82 page number and 81 page number, if you'll see 4.3.10 example. So this is also 10 marks question. 81 page number 4.3.10. Next 82 page number 5th question and 6th question. 5th one already have told. 6th one you just see once. Next 83 page number 4.4.1. Find the nth derivative of y equals to 1 by a square minus x square. This is also the 10 marks question. So you may get in any one of the series. That is ABC series will be there, no? So in any one series, you will get this for the 10 marks question. Here also just these are in the form of rational functions. That is a partial fractions will be there, no? So first you convert them by taking a by ax plus x plus b by a minus x. After that, if you do the cross multiplication and if you substitute x value as a, you will get the b value as 1 by 2a. If you substitute the x value as minus 2a, you will get a value as 1 by 2a. And if you just follow the, that is ax plus b to the power of n, nth order formula is there, no? If you apply that one, you will get the answer. Okay. So try to practice the 4.4.1 problem. Okay, it is a 10 marks question. Next, we have 85 page number and 84 page number 4.4.3 and 85 page number 8th question. Find the nth derivative of y equals to x by x square plus ax square. So this check your progress. You have the solution in your textbook. So once you see that, so whatever the questions I have given, these are the 10 marks questions. And in this one, in Leibniz theorem, 11th question, page number 89, I have told the 11th question. You see the 10th question. 12th is not important. You can see the 10th question in the textbook, and even the this 4.5.4 example, you see, find the nth derivative of log x by x. Just you practice that one, that's enough. So by this, we are completing the 4th unit. Next, we are going to the partial differentiation Euler's theorem on homogeneous functions. Okay. In this unit, only one 5 marks question and almost 2 questions you will get for the objective type. So 7 marks you will get in this unit if you are perfect with this one. So compulsory, damn sure, one question on Euler's theorem, homogeneous function, you will get 1 question. And any function will be given, and you will ask the degree of that function. That is 1 mark you will get in the multiple choice. And even you may get the formula of what is the Euler's theorem. So 7 marks are compulsory from this unit. 10 marks question you will not get, but 7 marks you will get from this problem. So in this unit, you have the, actually in unit 1, we have seen the, what is the limit definition. So limit definition we have seen whenever only one function is given, that is we have seen for the function y equals to f of x. And the limit formula was limit x tends to a, f of x equals to L. And here we got x less than x minus a, 0 less than x minus a less than delta. Okay, these all conditions we have seen, and even this also f of x minus L less than epsilon. Okay, for the limit, whatever the definition is there, the definition we have for only one function. So in 5th unit, we have the concept of the partial differentiation. So partial differentiation in the sense any function, z is any function such that it is of the combination of another 2 functions. So z is equals to f of x comma y. So 3 are variables here. X is one variable, y is one variable, and z is a one variable. So z is a function of the combination of x and y, means 2 variables are there. And here the functions will be 2 functions will be there. Okay. So such type of representation will do for the partial differentiation. Okay. Z equals to f of x comma y. Z is the dependent variable and these 2 are the independent variables. Okay. So for single function, we have the limit definition like this. Whenever 2 functions are there, we have the limit definition as like this. Limit x tends to a comma b, f of x comma y equals to L. And here whatever the condition is there, limit 0 less than. So same you will have, that is for epsilon greater than 0, there exists delta greater than 0, such that, so like this you will have x minus a whole square plus y minus b whole square less than delta square. And here this is mod of x comma y minus L less than epsilon. And the limit like this. So this is the difference between one function is given. This is the limit formula and these are the 2 conditions. Whenever the function is in the form of like this, you will have the limit definition as limit x tends to a comma b, f of x comma y equals to L. And this is the condition instead of this, and this is the condition instead of this. And why we are taking this definition whenever 2 functions are there means, if you'll see for this function as a graph, So if you can see, this is any one function y equals to f of x, and here x coordinate will be there and y coordinate will be there. Any function is passing through the origin. Okay, you will have like this. So if you'll see any point on this function, to reach that point, we have only two methods. Okay, or you can say only two ways or two paths. That is, from here you can go to this point, or from here you can go to this point. That is from upside or from down to up. Okay, only two methods are there to reach this point whenever you have only one single function. Okay, so that means it may be right hand limit and also left hand limit. So whenever you have the two functions, you will get the graph. Okay, whatever the graph is there, that graph in the three coordinates, that is x and y and z coordinates. So whenever three coordinates you are getting, you will get any one circle, as sphere, as cylinder, or cuboid, such type of. Means here the only any line surface you will get. But here, whenever two functions are there, whatever the graph is there, that graph is that you will get the plane surface. Plane surface means any three-dimensional figure you can get that one. So in any three-dimensional figure, if you take any point on this one or here or anywhere, okay, to reach or here also you can take. So anywhere if you take that point, you will consider this one. So to reach this point, you have infinite number of ways like this, infinite number of ways. So any point in plane, what will happen if you have here? So like this, many surfaces, you will get many different, infinite you can tell, infinite number of ways to reach that point. So in that ways, you may have the some parts like this. Even this also it will be there here, no? Y equals to mx is one path, y equals to mx square, y equals to mx cube, like the different paths will be there. So that's why whenever, and actually this concept you have in practical classes. So if you know somewhat here theory, you can easily do in the practical. That's why I'm telling this topic. So almost on this, you will not get any type of questions. Even 5 marks questions also rarely they will ask one problem on that. So first thing is, here will not find for finding any limit function, will not use RHL and LHL. We'll find only for the path y equals to mx and y equals to mx square. Two paths we'll find. If all the values are same, then the given limit function is satisfied, we'll tell. Same similar way, if we this limit extends to a comma b f of x comma y equals to f of a comma b, then this is called as continuity of the functions, continuity of the two functions. So the definitions are there in 98 page number 5.2.3, 5.2. Whatever is it, 2.7 you have, and 5.2.8 definition of continuity is there. Okay, if you'll see one problem on this one. So just to understand the concept of a limit of a function when two functions are given. So like this, the problem will be like this. Show that limit x comma y 0, 0 2xy square by x square plus y square. Okay, exist or not? So this exists. The function will be given like this. So what is the function? Limit x comma y tends to 0, 0, 2x by y square, x square plus y square. So this limit exists for this problem only. You can show that even continuity also satisfies. So here for such type of problems, you will not use RHL and LHL. Directly we solve how means limit x tends to 0. We'll write like this, y tends to 0, 2xy square by y square. Okay.
It's y power 4, ma'am. Am I correct?
Yeah, correct. Y power 4 by. So limit x tends to 0, you take outside, and inside you write limit y tends to 0, 2x y square by x to the power of 4 plus y to the power of 4. Okay. So directly what you'll do is here x comma y tends to 0 comma 0. You can write separate like this. X tends to 0, y tends to 0. X tends to 0, you keep constant, and inside you take limit y tends to 0 and this one. That means here in place of y, we have to substitute the y value as 0. So what will happen? This is numerator, it will become 0, and in the denominator you will get is limit x tends to 0 by 0, no, so 0 by this is what x to the power of 4 you will get. Okay, so already 0 by this means it is 0 only, no, so no need of substituting the x value as 0. So this value is 0. Okay, or else limit of 0 value is 0. So when you take the second one, so instead of RHL and LHL, we'll write like this: y tends to 0, x tends to 0. First you then you write denominator as a there is upside second value as 1 value as second one. 2x y square by x to the power of 4 plus y to the power of 4. So this is limit y tends to 0 of limit x tends to 0, 2x y square by so here substitute the x value as 0. So 0 by this one. So 0 by y to the power of 4. This value is also 0 we got. Okay. So both the values we got the same one. So what we have to do means these two are same. So one path is this one, another path is this one. So instead of writing the RHL and LHL, whenever it is a plane surface, we are choosing from the infinite number of paths, only two paths, no? That is, we have to write along the path y equals to mx. Okay, this is one path. So what will happen? This is limit x tends to 0. What is y value? Y equals to mx. 2x y square by x to the power of 4 plus y to the power of 4. So it is limit x tends to 0. Here you write limit y equals to, that is mx. So the R is one more step it will go. You just substitute the y value as mx. So when you substitute the y value as mx, what you will get? 2x mx whole square by x to the power of 4 plus mx to the power of 4. So it is limit x tends to 0. This is 2m square x to the power of 3 by x to the power of 4. If we take out common, what will happen? 1 plus m to the power of 4. Okay.
For x, the power is 2, ma'am,
Yes. This
in
is
the question itself.
that is 4. Here the value will not change, but here it will change. Okay. So what will happen? This is 2m square x cube by x square into this. So when you cancel out this, it is limit x tends to 0. 2m square, here 1x is there, x by 1 plus m to the power of 4. So now substitute the x value as 0. What will happen? 0 by this one. So you will get this as 0. Okay. So this is the same answer what you got above. Here we got this as 0 and this as 0 and this as 0. So now we'll see another path, that is along the path y equals to mx square. So in some problems, what will happen means this you may not get 0. So then the limit does not exist for first one, second one, third one, and fourth one. If you'll get the 4 values, same value, then the limit exists. If any one of the value, if you are getting different one, then the limit does not exist. Okay. Limit x tends to 0, y equals to mx square. And this is 2x y square by x square plus y to the power of 4. So it is limit extends to 0, substitute y value as mx square, that is 2x m square x to the power of 4. X square whole square, no, x to the power of 4, here 1x is there. We can write x to the power of 5.
Ma'am.
Hmm?
In that last, x square will get, ma'am.
What,
In
ma'am?
the last, ma'am, last sentence. Limit extends to 0. Last 2m square into x by 1 plus m power 4 into x square.
X square we have cancelled the numerator and denominator, no, here? This x
No,
square,
what she's telling is, ma'am, after taking common as x square, 1 plus m power 4 into x square. Whatever the value is, the final
okay.
value must be 0, right?
Yes, understood. Why? Because here only x square we have taken in common, not x to the power of 4, no? So x square when you take common, 1 plus m to the power of 4 x square. This also what will happen? You will get 0 by 1. This 1 plus this is 0, no? This is the power
Yeah,
of
so
4.
whatever it is, the value is 0, ma'am. Right?
The value is 0. Okay. So here m square, okay, y equals to mx square. So m square will get x square is x to the power of 4. This is one more x is there, x to the power of 5. Now here this is x square plus this is m to the power of 4 and this is x to the power of 8. Okay. Now, so limit extends to 0. 2m square x to the power of 5. Now x square if we'll take common, 1 plus m to the power of 4 into x to the power of 6. So this both if you'll gets cancelled. 2m square limit extends to 0. X to the power of 3 will be there. And here 1 plus m to the power of 4 x to the power of 6. Now apply the limit as x tends to 0. So in the numerator it will become 0 by 1 equals to 0. Okay. So all the 4 values we got the same. So whenever you get like this, but this is the difference between that first unit limit and this unit. If you have only one function, we'll find LHL and RHL. If both the values are same, then the limit exists. Whenever we have the function of 2 functions here, we have to find the first one, 2. Now we have done no x tends to 0, y tends to 0, that 2. And after that compulsory 2 paths we have to take. That is y equals to mx path and y equals to mx square path. Some other paths will be there, but for our solving such type of problems, we are using only 2 simple paths. That is y equals to mx and y equals to mx square. So if for this problem only is asking, show that this limit is he will give the function and he will tell that whether it is a continuous or not, means what is a continuous formula, that is f of 0 comma 0. Substitute in this one, x value as 0 and y value 0. So what will happen? This is 0 by 0. This is 0 plus 0. Okay. So this will be such type of problem will be not there. Why? Because 0 by 0 means it is an undefined one. So whenever if you get 0 by some value, if you are getting anywhere, then you will get that. If you are getting that value as 0, then this 4 values and this f of 0 comma 0 value, if you are getting same, then the same given function will be a continuous function. Okay. Here it is not a continuous function. Why? Because if you substitute x value, y value, what is happening? Here 0 numerator you are getting, in the denominator you are getting 0. So it is an undefined form. So only for this one limit exists, but it is not continuous. Okay. So in any problem, if he's asking, if you'll get the 5 values same one, then that function is a continuous function. Okay. This is the simple concept you have in this. For this only 5 marks question, you'll get any rare cases they will ask this question, but you have this concept in your practical examination, it is there, you will get there. Okay, next we'll go to the partial derivative. So we know already the concept of the partial derivative, that is any function z is any independent function which will be in the form of f of x comma y. Okay, so if we'll take any one z equals to x square plus 2y square or anything. Okay, so how you'll do the first representation of partial is this one, dou by dou x with respect to your function z. Okay, dou represents the partial differentiation. Remember that one, d represents the normal differentiation. So dou z by dou x, and partial differentiation is that one. We'll do the differentiation with respect to of the variable separately. X variable will do separate and y variable will do the separate one. So dou z by dou x is 2x, and this is the constant term. So we consider the other variable as a constant one, and that constant differentiation is 0. So this value is 0. Next to dou z by dou y, if you do, this part is 0. Why? Because with respect to y we are doing, and this is 4y. Okay. So this is the concept of the partial differentiation. If you do one time, it is called as the first order, but the formulas does not change for the derivative and partial derivatives. Okay. The whatever the x square formula is 2x and sin x is cos x, same will be there, but the representation of the differentiation is different. We'll write the dou, and the procedure for finding the partial differentiation is different one. So if we'll take this one only, z, any function f is there, x square plus 2y square. If you do the normal differentiation, what will happen? If you take dou f by dou x, df by dx, what will happen? 2x square. X square differentiation is 2x, and we'll write dx by dx plus 2y square is 2 to the 4y into dy by dx. This is the normal differentiation. That is combination of the two terms at a time we can do the differentiation. But whenever it is a partial differentiation, you will do the separate differentiation. So that is the difference between these two differentiations. Okay, try to remember that one. And here, if it is a first order, even will represent like this. It is called as a first order. If you write 2 times x, it is called as the second order. And if you write like this, second order with respect to y. And if you write this like this, z x y, z y x, this is also second order only. That is keeping one as constant, another one we are doing. So these whatever the 6 representations are there, they are considered as these two are first order, these two are second order differentiations. Okay. One problem they will ask for the 5 marks question to find the first and second order of the given any function. Okay. So if you'll see one small example, even for the multiple choice also, there is any objective type of questions also from the partial differentiation they may ask in the examination. Why? Because only within the one step you will get no. So you can see, find the partial derivative of any function like this. If you have z equals to tan inverse of x plus y is there. For this one, if you find the partial derivative, what how you do? That is, if you take this as 1, differentiate 1 partially with respect to x and y. So if you'll do with x, what you'll get? Dou z by dou x. This is in the form of tan inverse of x. So tan inverse of x differentiation is 1 by 1 plus x square. So even if you'll do for z, y also will get the same one. 1 by 1 plus x. Okay. So here again x differentiation is 1. Here y differentiation is 1. Okay. But the value is same for if we'll do with respect to x and y. Okay, this is the simple one. And next, if we'll do one more problem is there, find the first and second order partial differentiation of the given function. And the function is, I'm not writing the whole question, just you write the question. X cube plus y cube minus 3axy. Okay. So this is one of the function. For this one, find the first and second order partial differentiation. Okay. So you take this as 1. So differentiate 1 partially with respect to x and y. So I am representing like this, zx equals to. So here x cube differentiation is what? 3x square, and y cube is 0. And here x is there. So x value is 1. So minus 3ay. Okay. Next is zy. With respect to of y, if you do y cube differentiation is 3y square minus y value is 1, 3ax. Okay. Here you write differentiate 2 and 3 with respect to x and y. So what you'll get here? Zxx. So second order you're doing. So 3x square means 6x, and this value is 0. And next is zyy. Here 6y. Here y is not there, no. Wherever y is not there means that is the 0 value. And one more For the second order, you can write one more, no, that is z xy. Z xy is equals to, we can represent like this, dou z by dou x and dou y. Okay, so this is dou by dou x into dou z by dou y. What is dou z by dou y value? This one, 3y square minus 3x. Okay, so dou by dou x of this value means this, here x is not there, so this value is 0, here x is there, so that value is 1, so minus 3a. Next, if you do zyx, that means dou z by dou y into dou x, that is dou by dou y into, what is dou z by dou x value? This one, that is 3x square minus 3ay. Here y term is not there, so this value is 0, and here y term is there, and that y value is 1. So you have the answer is 3a. So both the values are same, no? So here we can write, therefore zxy is equals to zyx. And you at last you mention what are the all the first order and second order values. Okay, like this you have to solve the any differentiation problem. If you have partial differentiation means you have to follow this procedure. Okay, so on partial differentiation, almost you will get the questions for only 5 marks questions you will get. So page number 103, you have the formulas are there here, and that is a u plus v, and also same differentiation how you have the formulas. Here also for partial differentiation you have the formulas. If z equals to u plus v, what is the formula? Means here with respect of x we have to do, and also with respect of y we have to do. And uv rule also there, if you will the second one. So 103 page number, whatever the note you have formulas, these are important even for the objective type of also. Objective type questions also they will give, or else you will get the even in the fill in the blanks also. Okay, 1, 2, 3, 4 formulas. So you put the star mark for this one. So now we'll go to the homogeneous functions. If you see the concept of the homogeneous function, while telling the introduction, I have told the what is the concept of the homogeneous function. Homogeneous function means the function will be in the form of f of x comma y equals to, that is a naught just wait, I am writing on the board. So a naught into x to the power of n into y plus a1. So that will be in the form, if you convert that into the x to the power of n pi of y by x form, then you will have the homogeneous function. And in this, if he is asking the degree, what is the degree of the homogeneous function, the type of questions you will get for the objective type. Okay, so in this unit, one problem you may get as a partial derivative first order, second order for 5 marks, or else Euler's theorem is there, no? Euler's theorem problem compulsory they will ask. Okay, it may be 4th or 5th question, 4th question only. Why? Because it is the second block, no? So 4th question will be from this unit, and compulsory it will come, and 2 objective type of questions you will get. So totally 7 marks you will get from the unit 5. Okay, so homogeneous function means, so the function will be in the form of f of x comma y equals to a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 y square plus an x to the power into y to the power of n. Okay, like this the expansion will be there. So when you take out x to the power of n common from this, what you will get? A naught plus a1. This is your y is there. Here a power n if will go means x will be remain. So it will be in the form of y by x. Okay. Next it will be a2 y by x whole square. So an y by x to the power of n. Okay, like this, whenever you take the common, if any function is given, if you take x to the power of n term common and you are getting it as x to the power of n into yx to the power of n, whatever the power it is there in the problem, that power is called as a degree of the homogeneous function. This is one method, and we'll write it as x to the power of n pi of y by x to the power of n. Okay, if any function f of x comma y, it can be written as x to the power of n pi of y by x to the power of n. So such type of function is called as a homogeneous function. So another one is, if we can write it as y to the power of n pi of x by y to the power of n. And then from this, if we'll take y power n common. So such type of x a naught x to the power of n or a1 x to the power of n minus 1. From this, if we'll take out x to the power of n common, like this form, if we'll take y to the power of n common, it will be in the form of x by y whole to the power of n. So such type of two conversions is called as a homogeneous function, and whatever the n value is there, it is called as a degree of the homogeneous function. Okay, and another simple method is to find the degree of the homogeneous function, that is delta. If you take in place of x, delta x and delta y, and it is written as delta to the power of n f of x comma y. This is one of the alternate method. So in problems, you may have some confusion by doing like this. So if any confusion is there, directly the second method you can do. With the help of this also, you can find the degree of the homogeneous function. You can take like this, the function is there, f of x comma y is equals to x square minus y square by x cube minus y cube. Okay, so here you can take x square common, here you can take y cube common, and from that, if you will cancel, you will get the what is the degree of the homogeneous function, first method. And second method, this is the very simple one. You can take, instead of x, you can take lambda x, that is, this is lambda square x square minus lambda square y square by, this is lambda x cube minus lambda cube y cube. So what you have to get, if you will take out lambda common, x square y square you'll get, and here lambda cube, if you will take common, x cube minus y cube. If you both cancel out, here in the denominator lambda is there, that is lambda to the power of minus 1 x square minus y square x cube minus y cube is what is that? This is the given function, that is lambda to the power of minus 1 into f of x comma y. What is the degree here? Minus 1. Minus 1 is the, that means here whatever n value is there, we got the n value as minus 1. So minus 1 is the degree of this homogeneous function. Here something of that you got the same function. This is the degree and this is the function. Whenever you convert that, whenever conversion is there as a given function, the such type of functions are called as homogeneous functions. Okay, one example problem is there in your textbook, which is not a homogeneous function. So whenever it is not a homogeneous function, you will not have the degree of the that function. Okay, so like this, any example problems they'll give and they'll ask what is the degree of the homogeneous function. Okay, next on this homogeneous function, you have the Euler's theorem is there. This is the important one. Sometimes even the what is the formula of the Euler's theorem is also asked. Even representation of like this also in math, the following they'll give homogeneous function representation. Here they'll give A, B, C, D options. From this you have to choose which one is in the form of homogeneous function. Okay, next we have the Euler's theorem. You have it is 130 na. So next Euler's theorem formula is there, that is z equals to f of x comma y is a homogeneous function of degree n in x comma y, then x into dou z by dou x plus y into dou z by dou y equals to nz. This is the Euler's theorem. So this representation also you may get for 1 mark question in the examination. So on Euler's theorem also you have the problem is there. So how to find the Euler's theorem? So that problem we'll see tomorrow, and we'll see the 6th unit. Okay, 6th unit we have 3 theorems are there. 3 theorems, we'll see the 3 problems. For one theorem, we'll see 1 problem, and whatever the proof is there for these theorems, you have the proof in your textbook. So almost sometimes they will ask even proof also, state and prove the Rolle's theorem or Lagrange's mean value theorem or Cauchy's mean value theorem. Okay. Already it is 1:15. Okay, you have another class, I think so. So
Ma'am, didn't they ask proofs for today's theorems, what you have discussed earlier?
what, ma?
Didn't they ask theorems of Euler's theorem or what we have discussed today?
Theorem
Didn't they
proof
ask
your
theorem proofs? Yes, yes, ma'am. Statement and
no,
proof.
no. The whatever the Leibniz theorem is there, and even
Yes,
the Euler's theorem, just they are useful for solving the problems only.
Okay,
So
okay, ma'am.
statement and proof for this one are not important. Okay.
Okay, ma'am.
Only,
Thank.
the theorems are from the unit 1 you have, and also unit 6. So
Okay.
these only almost in first semester, some theorems proofs are almost they are not asked. Only the problems depending on those theorems. Sometimes only statement they will give. That is also from 6th unit only. You have the 3 theorems are there, no?
Yes,
So
ma'am.
only statement will be
Rolle's
for,
theorem.
and for the problem you will have the 7 marks. So totally it will be for 10 marks question. Okay.
Yes, ma'am.
Tomorrow we'll see the last 6th unit, and also in block 3 and block 4, I'll give the important questions. Okay.